Oh, there's Linda. Hi. My instinct is to look at you on my screen, but I'm going to face the camera. Hi, Linda.
Hello.
So good to have you here. So good to hear your voice. So good that you can hear my voice. You can, right? Like this we've all been there. Good to hear. Please, take it away.
Thanks so much, Peter. I am so excited and honoured to be one of the keynotes for PyCon AU this year. I am devastated not to be with you in person, and I'm sensible of the irony that I got COVID right before going to the safest possible conference I could have gone to. And thank you so much for making it a safe conference by doing all the masking. That's just wonderful. Huge thanks to PyCon AU organisers and Ryan and the Next Day video team for making this possible, for making it possible for me to present online. Because I'm all the way over here and not in the room with you, I'm going to need you to emote at me really loudly. Don't be shy and tactful, laugh loudly, scoff intensely, let me hear your reactions. It actually sounds like the hall might have been muted a little bit for me, so if that doesn't work, pop all your stuff in the Goldfields chat. I really want to see some interaction. And definitely talk to me online afterwards. I'll give you a squillion ways to do that. So I'd like to begin by acknowledging the first people of the land that I am presenting from, which is the Bunyarong people of the Kulin Nation. They are our first scientists, our first storytellers, and our first communities. And this land was never ceded. Alrighty, let's do this. I want to talk today about feelings, because I don't think we talk about feelings enough in the tech industry. I've learnt a lot from my cat, who has big feelings about many things, including her preferred human leaving for work, the urgent need for snacks, and her desperate lack of playmates at 3 a.m. Also, as you can see in this picture, people who dare to move without permission. Outrageous. When she has big feelings, she likes to tell us about them at length, and I am currently having some really big feelings about the tech industry, so I'd like to tell you about those. The tech industry sells us smartwatches that can't actually reliably do any of the things that you buy them for. The most positive study of sleep trackers says they're 60 to 75% accurate at picking the sleep stage at best. In the case of my smartwatch, it has repeatedly claimed I was in REM sleep while I was having breakfast, making a cup of miso soup, and putting a load of washing on, which is really very productive for someone who's allegedly still asleep. My husband's Fitbit recently recorded him having a swim, only a short one, 208 metres, while he was folding washing. I like to imagine a series of parallel worlds where other versions of us are doing the things our smartwatches say they are. What's more, my watch can't even reliably tell the time, which just blows my mind. Periodically, as you can see in this picture, the hands on my watch just get lost and tell some completely other time. And I have to go into the app and hunt for the hidden function that realigns the hands, which is kind of weird because it says that this is clearly a known problem, and rather than fix it, they sneak a function into the app that you can use to recover from it when it happens, assuming you can find that function. Even step counting isn't terribly reliable. One study published in 2020 found that wrist-worn activity monitors such as smartwatches varied in mean average percentage error from around 200 to around 860%. That upper value means some activity monitors are recording over 8 times the actual number of steps on average, so sometimes it's a lot higher. And the most accurate was more than double. Now, that's over a full day. Walking briskly and purposefully is a lot more accurate. So clearly smartwatches are biased against the fine art of the amble. Not to mention the way they record clapping, washing dishes, and many other things as steps that are not, in fact, steps. My husband's Fitbit records him taking thousands of steps at the same time as riding his bike, which would be a really impressive achievement if only it were true. Similarly, on a recent road trip, I discovered that I took thousands of steps while sitting peacefully in the back seat of our car. The tech industry sells us robotic vacuums that will happily share live video footage inside your home with hackers, and new cars that are so pointlessly internet connected that they can be remotely controlled using the car's license plate number. Tesla markets an autopilot that is in no way safe to use unsupervised. And make no mistake, calling it autopilot while the fine print says it's your responsibility to pay attention because it's not actually an autopilot is an incredibly arrogant and appalling way to dodge responsibility for a system that's not fit for purpose. Tech also sells us self-driving cars that have 2 human operators per car in a control centre, monitoring them for problems, which introduces all kinds of issues of reaction time and latency, but sure, they are self-driving. Well, of course they are. Tech sells us perimeter intruder detection systems that can be fooled by boxes, giggling boxes at that. And facial recognition systems that can't tell people of colour apart, not to mention blood oxygenation meters that don't work properly on dark skin. And now, of course, it's selling us artificial intelligence, with Google CEO Sundar Pichai claiming that Google has a system that's showing emergent behaviour, doing things it was never programmed to do. Spoiler alert, it does not. Microsoft's Bill Gates says the amount of energy used by AI doesn't matter because AI will solve climate change for us, in the complete absence of any evidence of AI ever having solved novel problems. Sure, in some specific cases, it's excellent at doing things it has been very precisely and carefully trained to do, things we already know how to do. But it has never yet solved a problem it hasn't been taught to solve by someone who has already solved it. We have no evidence that it will ever be capable of solving climate change, but every evidence that its voracious appetite for energy and water are rapidly making climate change worse. And, of course, there's more and worse. AI chatbots encouraging teenagers to kill themselves. Chatbots in healthcare making up symptoms and treatments, and chatbots reporting entirely fabricated criminal histories. But I'm going to move on because we could list AI fails forever and make no progress. The thing is, people really want to believe that AI is or is about to become sentient. Even the folks who think it's going to kill us all seem to think that would be an excellent or at least really exciting outcome. On Gruen this year, Todd Sampson said, AI is possibly the most profound transition we will definitely experience in our lifetime. And on the couch this year, Linda McIver said, it's really not. So I don't know whether I'll hear you, but I'd like to have a quick poll. Are you Team Linda or Team Todd? So shout yay if you're Team Todd. Now shout nay if you're Team Linda. Nay. There we go. That's my people. So the idea that large language models will magically become intelligent, life-changing, problem-solving creatures is like believing that you can drop a large amount of dry spaghetti into a bucket and if you stir it enough, it will create a perfectly scale replica of the Eiffel Tower. It's just not how they work. The AI industry's infinite number of monkeys will never produce Hamlet in real life. But it's not the general public's fault that we're so credulous, so willing, so desperate to believe in AI. We are literally being hyped into it. The AIs themselves are designed to maintain the illusion. I asked Claude recently to summarise a chunk of text into 200 words, and like they all do, it produced 232 words. So I asked it why it can't count. And this is what it said. What do you notice about this response? It said, I apologise for my mistakes. You're right to point out these errors, and I appreciate your patience. The truth is I can count and I can adhere to word limits, but I made careless errors in my previous responses. These mistakes were not due to an inability to count, but rather a failure to double-check my work carefully. To be clear, I am capable of accurate word counting and of producing summaries to exact word limits. My failure to do so in this conversation was an oversight on my part. Thank you for holding me accountable. That bit really annoys me because accountable is the one thing AIs never are. In the future, I will strive to be more diligent in verifying my word counts and ensuring that I meet specified limits accurately. Now, the trouble with this, I see someone in the chat says it sounds like a politician. It really does. Maybe they're all using ChatGPT. That would explain a lot. Anyway, it's humanising anthropomorphic language. I apologise. I appreciate your patience. I made careless errors. I failed to carefully double-check my work. I made an oversight. You're holding me accountable, and I will strive to be more diligent. But despite the apology, let's be clear, Claude was working exactly as intended, because large language models are not designed to produce facts, right answers, or anything at all accurate or reliable. They are designed to produce statements that are plausible. As Lily Ryan puts it, their statements are not facts, they are fact-shaped. And I'm going to take that further. Their summaries are not summaries, they are summary-shaped. And their solutions are not solutions, they are solution-shaped. And the systems are not people, but they are increasingly people-shaped. And this, too, is an entirely deliberate strategy, because, as Adrian Tchaikovsky so eloquently put it in his funny and deeply disturbing book, Service Model, humans have been reading personality and self-determination into inanimate phenomena since long before Alan Turing ever proposed a test. The level of complexity and interaction required for an artificial system to convince a human that it is a person is pathetically low. Making them as human-shaped as possible makes us more likely to want to interact with them, to believe that they are intelligent, and to pay for them to do jobs for us that they are in no way qualified to do. The trouble is, we're not by nature critical thinkers. We really want to believe. Ever since the world went mad for generative AI, I've been a little unclear as to my role. Am I Cassandra, doomed to see the future but never believed? The canary in the coal mine? The child who is the only person prepared to say out loud that the emperor is actually naked? Whenever I sound a cautious note, I get bombarded with, the old versions do that, but the latest versions are much better. The next version will be game-changing, or my favourite, these are the worst AIs we will ever use. The next generation is going to change the world. And my personal favourite, really, is this comment left on my blog. But LLMs are really good at language, and once you connect an LLM to a computational system, the game changes. Just as a human has 5 senses, an LLM with multiple sensory inputs will quickly learn to overcome all the limitations that you parody in this post, which, really, I have so many questions. But the idea that large language models can become intelligent given the right inputs rests on a completely false model of how LLMs work. To summarise, LLMs are computational systems, and they do not learn, even if you plug them into a nose. It has been suggested that LLMs learn from text online, that they read text and use them as inspiration. But like Terry Pratchett's Gaspode, LLMs don't so much read books as chew them. That's the Pratchett quote I was hoping people would catch online, but no one got it. I recently saw a person on LinkedIn unironically using ChatGPT to detect bogus chatbot-generated references, hence the Ouroboros, which is rather akin to asking that dude on Facebook whether the Rolex he wants to sell you is genuine. Only it's worse, because the dude on Facebook knows the Rolex is a fake. ChatGPT has no clue. It's not designed to have a clue. It's busily being marketed as game-changing, but the little objective research that I have seen done suggests it takes more time and effort to use than to do without it. So I keep wondering if there really is some secret AI that actually works that I'm missing, because people are so excited about it. And I've mostly played with text generators, so when my friend Robin told me she'd had fun trying to get a generative art system to give her a picture of a 3-legged puffin, I decided to try it for myself. It didn't matter which system I tried. It could show me a puffin, but never a 3-legged one. And I tried a range of prompts, starting with 3-legged puffin, and increasing in desperation through 3-legged puffin with 3 legs, to 3-legged puffin with 3 legs that actually has 3 legs, through to 3-legged puffin with 3 actual legs with the 3rd leg on its stomach. But as another stark reminder of the fact that these systems do not think, it has no way of producing a 3-legged puffin. That would require some level of understanding. What is a puffin? What is a leg? It doesn't know. But it has seen images labeled puffin on the internet, so it can give us something like that. It's really a pattern matching device with a little bit of mixing. Here are 5 images that kind of match your prompt. The system is going to combine them into one. But it's not copying copyright material. Oh, no, it's using it as inspiration, more humanizing language. But this is not what inspiration looks like. When you taste a cake and try to recreate the recipe on your own, that is using the cake as inspiration. When you throw the cake itself into the blender, that's not using it as inspiration, that's using it as an ingredient, which is what generative AI does. Generative AI throws all of its source material into the blender. Now, a human being, having never seen a three-legged puffin, but understanding the idea of both puffins and legs, could produce a picture of a puffin that has 3 legs. Wouldn't be very good in my case, but I could do it. That's using ideas as inspiration. And AI can't, because it uses previous images as content, not as inspiration. Generative AI does not, in fact, generate. It regurgitates. AI image generation is just like the claims made about AI. At first glance, it looks amazing, but when you look at it closely, the flaws are often obvious and really quite disturbing. So the entire AI industry is selling us the idea that it can do things that it cannot, in fact, do. Selling us the idea that it has already done things, like solve problems or teach itself new skills, that it hasn't, in fact, done. And for most of society, the sales pitch is working alarmingly well. And then when you add to that cases where tech companies have acted unethically, like the recent revelations that IMED has sold patients' X-ray data to a startup to use for training its AIs without any form of informed consent. And it's increasingly clear that we need to rein in the tech industry's behaviour. And technology is also wildly successful at selling us conspiracy theories, lies about health, lies about people, lies about politics, and lies about climate change, among many, many, many other lies. Last year, TikTok tried to take me down a rabbit hole of videos of people trying to break into hotel rooms. And I was sucked in for a while, but it really puzzled me that the women, it was always women, inevitably travelling alone, who were anxiously watching someone break into the room they were in, were filming it to put it on TikTok rather than calling the police. Each video seemed to escalate in creepiness and hysteria until I shook myself free. So I now skip any video that doesn't involve cute animals or David Tennant. Unless you constantly redirect it, the TikTok algorithm really seems to prioritise fear and rage, and I just don't need more fear and rage in my life. There's plenty. This year I decided to try Threads for promoting my work, and while exploring it and thinking about how to build a following there, I posted a small story about DoorDash, and I had like half a dozen followers at the time. And nonetheless, I experienced my first ever nutjob pile-on. It was bizarrely intense. The level of abuse and outrage was entirely disproportionate to the story. And of course, they hadn't read the post, they just responded to like a couple of key words. And it seemed to be getting noticed by a large number of people who weren't in my network at all. And talking to other tech friends about it, they've experienced the same kind of things. The outrage pile-ons happen really fast on Threads, even when you only have a handful of followers. They seem to have very effectively optimised the algorithm to maximise engagement using, again, fear and rage. And as if that's not enough, the tech industry sells us devices that will cease to function at all if the company making them goes under or simply decides not to support them anymore. For a doorbell or a thermostat, that's annoying and possibly expensive. For a door lock, it's a real problem. But for medical technology like a bionic eye, that's a nightmare. Technology does seem to choose to give us a lot of grief and fear and rage. And now, not content with merely spreading misinformation, the tech industry is using AI to generate more of it. Tons more. And yet, last year, technology also gave me 2 new hips, and I wish you could see me standing up because I can stand like a person with mobility and who is pain-free, and it's amazing. It radically changed my quality of life. I was able... Thank you. That's how I felt too. I could stand up fully weight-bearing as soon as I woke up from the surgery. Now, that is wild. Technology can be life-saving. AI systems can successfully identify some types of cancerous cells faster and more accurately than radiologists. Technology enabled the modelling of the SARS-CoV-2 virus that led to the incredibly rapid development of an entirely new class of vaccines that use novel techniques to vaccinate people against COVID-19. And part of the reason I'm actually upright and not bedridden is that I was boosted just 2 weeks ago, so some of my timing was okay. My friends at Pawsey Supercomputing Centre in Perth are using high-performance computing to develop technology that can monitor the vital signs of patients with traumatic brain injuries in real time, and it can predict potentially fatal pressure buildups in the brain before they happen so that medical staff can prevent and treat them. Technology is saving lives. Technology can examine aerial photographs of crops and identify the beginnings of diseases so that farmers can treat them before they spread. We can send scientists to space. We can photograph distant galaxies. And my personal favourite, my friend Darren can send me live footage of his cats in San Francisco while he's in New York and I'm in Melbourne. Before I got up to deliver this talk, my besties in Adelaide, Brisbane, San Francisco and Perth wished me luck, and my kids, several suburbs away, rolled their eyes at me in real time. So the answer is not to ditch the smartphone or condemn technology altogether. The answer is to critically evaluate technology, to critically evaluate information, and to ask rationally difficult questions. But to do that, we need the whole of society to be strong on critical thinking and to know enough about technology to know what questions to ask. Now, schools and universities will proudly and loudly tell you that they produce graduates who are strong in critical thinking. And, the curriculum is fine as far as it goes. There's a ton of useful stuff on there. The problem is not so much with the content as it is with the context. As long as we're teaching using problems that have answers that we can look up in the back of the textbook, as long as we're using exams to measure students' progress, or worse, to measure students, as long as we're asking kids to all do the same thing and assessing them on whether or not they got the right answer, and as long as we allow kids to think that their Year 12 results define them in any meaningful way, we are not teaching critical thinking. We are teaching compliance, and we are rewarding groupthink. We're teaching exam passing and getting the right answer. The trouble is, in real life, with real problems, there is no right answer. There are multiple solutions, each with different pros and cons. To figure out whether we've implemented a good solution, we have to critically evaluate it, figure out who it helps and who it harms. That's a really important one. When I was teaching, I first started using data science with my Year 10s because I wanted to give them a reason to learn programming. Before that, we had them drawing pretty pictures with block-based languages, teaching Lego robots to push each other out of circles, and experimenting with slime mould. And for some reason, they couldn't see the relevance of this to their futures. It's a mystery. Given that my purpose was motivation, it seemed important to make it real so that students could see how what they were doing could be used in other contexts. So we did projects on election data, on microbats, that's bats, not bits, and on climate science. And in every case, the data sets were large, messy, and complicated. Magnificently real. No clean data sets for us, thank you very much. And in every case, the overwhelming feedback went from, why are you making me do this? To, oh, this is so useful. I used it in my science project and in my maths exam. And oh my God, watching the news last night, there was a graph and it was so misleading because there was no zero on the scale. Like, yes! It worked a treat. Kids were more engaged and they learnt that coding was not only something they were capable of, it was something worth doing. Thank you so much for the emoting, it's really helping. And I could have left it at that, but the longer I worked with real data, the clearer it became that using real data had another benefit, which is that whole there's no clear right or wrong thing. So, let me explain. This is the first data set I taught my Year 10s with, which is an election data set from the Australian Electoral Commission. Over 3 million lines of CSV file, where each line was a Victorian vote for the Senate in the federal election. Far too big to open in Excel, they had to use Python to wrangle the data. Gosh darn it. We got the kids to figure out their own questions to ask of the data set. And with the data set that big and that complex, there were almost infinite possible questions. It was also incredibly messy. We taught the kids the rules of Senate voting in Australia, which is no small task in itself. And then we showed them the huge ballot paper and then opened the file to have a look. So here we have a CSV file with over 160 columns and 3 million rows. And we'd tell the kids that people could vote above the line or below the line, but not both. And so they would write code that assumed that if they found votes above the line, there would be nothing below the line. But of course, not everyone followed the rules. You can see in that very brief screenshot there, the 5th line of data already has someone who's voted above and below the line on the same ballot. Surprise! People, just like data, are messy, complicated, and often don't follow the rules. So this was a problem for the teachers I was teaching with at first, because the trouble with asking 200 students to find their own questions to ask of a large data set is that we, as teachers, aren't going to know the answers. Now, that turns out to be one of the best parts of the whole idea, because now, instead of marking kids right or wrong, The kids have to critically evaluate their own work. They have to explain where it works, where it falls down, and where they aren't quite sure about it. They have to figure out what other reasons there might be for the results they found. Suddenly, they have to ask themselves the question, how do I know that I'm right? Imagine if we had to do that for all of the projects we do, all the real problems we solve, not just in education, but in business and in government. So, now we're using real projects in class, we're finding fault with your own work is actually what gets you marks. Because we were getting the kids to solve real problems, using real data, there was no such thing as a perfect solution. There were always going to be issues. The standard educational approach is to mark right or wrong, and then we wonder why kids cheat when they don't get the results they expect in experiments and things, because they know that the important thing is to get the right answer. What if instead we taught everyone that the important thing is to think critically, to evaluate your solutions, to consider other possible reasons for the results that you found? Imagine how that might change society. So we're teaching programming using data. The kids didn't all write incredible feats of machine learning as their assignments, though some did. Many of them simply wrote a page of Python to extract some data from a CSV file and process it a little. They didn't even do the visualizations in Python. They did those by hand. Let's face it, Python visualization libraries are not super friendly to beginners, and I wanted them to be able to do really creative and compelling visualizations. So if they were doing something about microbats, I wanted bats on the graph, things like that. So actually, just writing a little code and writing it successfully was a massive achievement for some of these kids. They came into the course believing that coding was hard, not something they could do, and also completely irrelevant to them and their futures. And they dreaded it. They told me so. They left the course knowing it was not actually that hard. They were more than capable of doing it, and it was hugely relevant and useful for their futures. It turns out that learning a wide range of complex programming skills is far less important than simply learning that programming is something that you can do. Now, not only did we have a whole cohort of previously reluctant learners suddenly engaging enthusiastically with the work, we had a whole new set of kids choosing to do the Year 11 computer science subject, including double the number of girls who had chosen it before. I was successfully getting more kids into programming. And let's be clear, it's not just girls who are shunning tech in alarming numbers. They are just the easily measured ones. The boys and the non-binary kids who just don't think they can do it and don't see any reason why they'd want to are also a problem, because they too contribute to our lack of diversity. But the other reason I started doing data science with Year 10s was their science projects. Every kid at that school had to do an extended experimental investigation in Year 10, and they would do posters. And when I walked around at the exhibition night and looked at all the posters of their results, the graphs frequently made me cry. They were just so bad. But not only did the kids not know any better, their science teachers hadn't spotted it either. So it was starting to dawn on me that we weren't getting basic data literacy across to the kids, and we haven't been for a long time. You only have to live through a pandemic to figure out that very few people understand exponential growth. So what if we had 2, then 4, then 8, then 16 cases? Those aren't scary numbers. No, but they're a terrifying pattern that's going to be scary really soon. But exponential growth is in the curriculum. It's been there for a long time. So why doesn't anyone seem to understand it or recognise it when they see it? Well, I think it's because it never mattered enough to us to really learn it before. We learnt y equals x squared, and frankly, who gives a rat's? Once you start looking for it, data ignorance is everywhere. A journalist who I'm not going to name and shame, though I'm tempted, published this graph on Twitter. Well, what does it mean? I haven't trimmed it to trim off the labels or the axes. That was literally the JPEG. So when I pointed out that it wasn't actually meaningful, I got jumped on, and another journo DM'd me to say, we're all intelligent enough to know what that graph means. Okay, but it doesn't mean anything. It tells us there's been change, but we have no way of knowing what the change was or what the scale might be. Without labels and a scale, that data could be going up, down, or sideways by massive amounts or tiny or somewhere in between. The way he believed that we are all intelligent enough to know what it means is disturbing, because too often we underestimate our ignorance when it comes to data. And we are easily swayed by some statistics or by a pretty graph, without knowing what questions to ask to get a sense of what story the data really tells us. Now, I have a podcast called Make Me Data Literate, where I interview folks who do cool things with data. And I always ask them what the first question they ask is when they look at graphs in the media. There have been around 30 episodes so far, and there are some very strong themes that have emerged in response to that question. Number one, what's the source and what story are they trying to tell? Number two, check the axes. Does the y-axis start at 0? Does it go up linearly? The things that happen to y-axes out there should be banned by the Geneva Convention, let me tell you. What is the sample size is the other one. Now, many of us don't by default ask these questions, simple though they are, because we tend to bend at the knees when we see a graph and we assume the story it's telling us is valid. Imagine if we all knew enough to be rationally skeptical of those stories. So we all need to be data literate. We all need to be more rationally skeptical and better at critical thinking. How do we get there? Well, there are a number of roadblocks along the way. When I first started doing a PhD in computer science, my husband was doing a master's in electrical engineering, specifically about windmills. When we went to parties and introduced ourselves, people would ask what we did, and he'd say, I research windmills. People would go, oh, that's cool, windmills are nice. And I'd say, I'm doing a PhD in computer science. They would go, blah! And they would physically recoil, turn back to my husband with his nice friendly windmills and go, windmills, you say? I learned to say instead that I was doing a PhD in making computers easier to use, and suddenly I was extremely popular. Computer science is scary. So too is data science. People assume that it's hard, inaccessible, and not something they could ever do. This is, of course, nonsense. Anyone can learn to program and anyone can wrangle data, just like anyone can learn to be good at maths. But we don't see it that way because we don't teach it that way. We have teachers who believe that they are terrible with computers, teachers who are terrified of technology and of maths, especially at primary school. Kids believe their teachers are God, and if God is scared of this stuff, what hope do I have? But it's not the teacher's fault. They went through this same system. We taught them to be afraid of maths, and the tech industry taught them to be afraid of tech when it ate their work, crashed unexpectedly, or was just bewilderingly difficult to use. When I was writing Raising Heretics, I did some research into primary teaching degrees. Do you know how many core units most of those degrees have on computing or on data? None. None. None at all. Now, clearly, that needs to change, but it's no good starting at the tertiary level. We know that people's attitudes to maths and their ideas, their own abilities, solidify in primary school. By the time they reach high school, we've lost them. So we've got to go right back to the start and give kids a reason to learn this stuff, the idea that it's worth doing, and the belief that they can do it. Now, a lot of what I teach in my projects is already in the curriculum, but it's divorced from context. It's presented as knowledge for knowledge's sake. When I created my first data science unit, one of the teachers who had to teach it was a maths teacher. She gave me a really hard time about teaching graphs. Why are we doing graphs? We already do graphs in maths. It's pointless. You're just doubling up. And then she saw the finished graphing unit and she was blown away. This is so useful. I'm going to use this when I teach maths. I've learned so much. So this person with a degree in maths who'd been teaching maths for years did not really understand the real application of graphs. Take it outside of a textbook and it's useless. Sure, we can teach graphing the equation y equals x squared, but what's the point? We can't expect students to engage with this stuff that they know deep in their hearts is not relevant to them, it's too hard for them, or it's not interesting to them. We have to give them a purpose. We have to sneak them into it sideways. Not, we're going to teach you stuff that you hate, but, hey, here's a real problem. How can we solve it? And to do that, we need to build real problem solving into the curriculum and not just design thinking, plan a trip to Mars type rubbish. We have to get them solving real problems and implementing their solutions. And then, and this is the really important part, critically evaluating their solutions to see who they help, who they harm, and how they can be improved. Imagine if governments routinely did that. So I have a template for this kind of problem solving. First of all, find a problem the kids care about. It could be anything from litter to who gets access to the basketball courts, from traffic to how to cool down the playground. Something that matters to them, something that's relevant to this community. And then you get them to measure it, and that's, a whole topic in itself. How accurate are the measurements? How valid are they? What might change if you did it on another day? All that stuff. They analyze the measurements, and I don't care whether they do that with Python or whether they stack blocks, but they analyze them in some way. They communicate the results, they come up with a solution, they implement the solution, and then measure it again to see how well it worked. And that's the beautiful part, because the measurements will inevitably be flawed. All measurements are, and wouldn't the world be different if we all understood that a little better? What was different between the first time you measured and the second, aside from what you did? Was the weather different? Were people away? Was the traffic lower due to a rostered day off on the local construction sites? What other reasons could there be for the results that you found, and how could you test for it? And then you write a report about what you found, or you write a letter to the school leadership advocating for change with evidence, or you write a submission to the council or to the local public transport provider or the state government. You can cover nearly every subject in the curriculum with a project like that. English for the communication, maths for the analysis and graphing, art for the visualization, science for designing experiments to measure the problem and potentially for topics around the problem itself, geography for the people and place aspects of the problem, history for the origins of the problem, and of course, computing all the way through. And that's why I created the Australian Data Science Education Institute, or ADSEI. ADSEI is a charity dedicated to building the critical thinking, data literacy and STEM skills of all Australian students from childcare to university. We design projects based on that template, and also projects to analyse existing data sets on any topic you can think of. We curriculum link them, and we train teachers in the data skills necessary to teach them. And a lot of that training is really just confidence building. We have learned to be afraid of maths, afraid of data, and particularly afraid of technology. So if I can teach them that they already have those skills and just need to use them in a different way, we're off and running. Some example projects include exploring the difference between a single house installing solar panels and an entire community doing so individual versus collective action. An exploration of pocket inequality, I love this one, where kids count the pockets in men's, women's and unisex clothing and evaluate their effectiveness, thus accounting for those. Thank you, that's my favourite. Thus accounting for those uselessly shallow pockets that actually entrap you into dropping your phone, or the fake pockets, don't get me started on fake pockets. And a study of the differences in the sleep habits of different age groups, or collecting data, I like this one too, about how much further people have to go to use the accessible features of a venue, like the lifts or even just pressing the button to get out. And then reporting on it. Evaluating the impact of mindfulness and wellness apps, evaluating the accuracy of different weather prediction apps, collecting data about the usage of different social or activity areas in the school grounds and coming up with strategies for democratising access to them. Doesn't really matter what the project is as long as it's meaningful. Now, one of my former students who now works with data professionally once told me it was because of me she was in this job. She said, "You're the one who gave me the confidence to play with data like silly putty." I just love this quote. Giving teachers and hence students, you folks are fabulous. And giving teachers and students that confidence is a huge part of what I do, but it's also very much about the critical thinking. If they don't have right or wrong answers and they can't look them up in the back of the textbook, then they have to learn to critically analyse their own work. Suddenly, we're not rewarding right answers, we're rewarding them for identifying the problems with their own work. So you take out the defensiveness, the obsession with perfection, and the need to be right, and you replace it with the knowledge that your work isn't perfect and that identifying how it's not perfect is the thing that matters. Just pause for a moment and consider the difference it might make to the world if we didn't learn we had to be perfect, if we learned we had to be thoughtful instead, if we learned that nothing is perfect, even our own work, and everything needs to be critically evaluated. In Diamond Age, Neil Stephenson wrote, "The difference between stupid and intelligent people, and this is true whether or not they are well educated, is that intelligent people can handle subtlety. They're not baffled by ambiguous or even contradictory situations. In fact, they expect them and are apt to become suspicious when things seem overly straightforward." I really like this definition, and it means that by teaching us simple, neat, perfect scenarios, our education system is actively making us stupid. Now, I hesitate to say this at PyCon of all places, but once I realised that these projects could actually teach kids to critically evaluate their own work, I stopped caring about teaching them programming. I'm so sorry. I don't care whether they use Python, Tableau, Excel, or pen and paper or blocks. It's the critical thinking that matters. It's the values that we're teaching them. Because assessment Whew, I got away with it. Because assessment inevitably teaches kids what we care about. And for too long, it's taught them that we care about right answers and memorization, regurgitating facts and applying known processes. Does that sound familiar? Rather like AI. When we could be using assessment to teach them that we care about creative problem solving, critical thinking, and identifying the problems with their own work. We could be teaching them that they have the power to change the world, that what they do matters. So instead of using assessment to teach kids to follow rules and produce the right answer, let's use it to teach them to be rational skeptics, critical thinkers, and absolute troublemakers. Because troublemakers are the ones who are creative enough and radical enough to solve the hard problems and to change the world. All right, so if I figured out how to engage kids with STEM and how to teach critical thinking, how to motivate kids to learn programming, why am I not working with kids? Why work with teachers instead? Well, in a nutshell, my goal is to put ADSEI out of business. I recognise this is a weird thing for a founder to say. But if I run after-school programs or school incursions or anything else that has me working with kids, it doesn't scale. If I work with 30 kids, I've worked with 30 kids. But if I run just one workshop with 30 teachers, each of whom has up to 12 classes per year, 6 per semester, 25 kids each, I've worked with up to 9,000 kids per year just from that one workshop. And it's more than that because my goal is systemic change. This is why I say I want to put ADSEI out of business, because I want this to be the way where teachers teach. I want it to change the curriculum. I want to change the teacher training, the whole system, so that ADSEI also works in the policy space, advocating for change, advising on curriculum, and generally being the kind of troublemakers that we say the world needs. When you design a new course, the best practice is to spell out very clearly and explicitly what the purpose of the course is. What we really need to do now is to redesign the education system and to spell out very clearly and explicitly what the purpose of education is. What are we trying to do here? Here is what I want our education system to do. I want it to produce critical thinkers, creative problem solvers who critically evaluate their own solutions, challengers of the status quo, people who ask why, evidence-based policymakers, people who look at smartwatches that can't tell the time and chatbots that can't tell the truth and ask why, people who say do better and who know how to measure what better looks like. Now, I've put this in the context of the tech industry because this is mostly a tech conference, but we can apply it to medicine, to government, and to business just as easily. We absolutely need to apply it to climate change, pollution, and species extinction. We need to apply it to the housing crisis, to income inequality, to politics, and definitely to media. I put my blood test results from the last 12 months into a spreadsheet recently, and I figured out patterns and issues that were invisible to my GP, who was comparing one test to another by looking at those printouts that path labs send and looking for the bits in bold. Why aren't we teaching our doctors to manage data systematically? How many developing issues go unnoticed because all they know how to do is to look for those items in bold that are outside the expected range? What we can build this way is a world where policy is evidence-based, where we make data-informed decisions while understanding that the data isn't perfect, where kids are empowered to learn all of the skills they need to solve problems in their own community, where technological solutions are rationally evaluated rather than uncritically worshipped. Imagine the world that we could create. And here's how you can help.
Thank you very much, Linda. As someone who loves a good graph, I could not have said it better. I do have for you this wonderful speaker gift. It's a mug. It's difficult to pass through the camera, so we will arrange to get it to you, don't worry.
I appreciate that.
It's difficult to facilitate questions over a link, so Linda is very keen to answer questions, but I would like you all to take them to the Discord. Questions, chat. Goldfields Theatre is the room for this. We're in the Goldfields Theatre. Any talks in this room, including Linda's wonderful keynote. Thank you, Linda. Jump in Goldfields Theatre in Discord. Tell Linda how much you loved her talk. Ask her questions. Linda will be there to chat. Once again, thank you very much, Linda.
Thanks so much.